Have you ever stood beneath a clear, moonless sky, far from the city lights, and felt the crushing weight of the silence above you? It is a silence so old that it predates the very ground you stand on, a quiet that has swallowed the screams of dying stars and the birth cries of entire galaxies. We look up, and our brains try to tell us that we are seeing everything, that the dome of night is the whole of existence, vast and unending. We feel small, and in that feeling, we find a strange comfort. We tell ourselves that Earth is a speck of dust, that our sun is just one of billions, and that the Milky Way is a grand spiraling island in the dark. We construct a mental map of the cosmos, where galaxies are the giants, the supreme rulers of the void, drifting like solitary ships in an infinite, empty ocean. But what if that feeling of smallness was based on a lie? What if the galaxies, those majestic swirls of light that we have spent centuries admiring, are not the giants we think they are? What if, in the grander scheme of things, a galaxy is not a ship, but merely an atom, a tiny, insignificant particle locked inside a structure so monstrous, so impossibly vast, that the human mind physically recoils from imagining it? There is something out there, hiding in the deep dark between the constellations of Hercules and Corona Borealis. It is a thing that defies the laws of physics as we understand them. It is a thing that, according to our best theories, should not exist. And yet, there it is, a silent titan stretching across the cosmos, making our entire Milky Way look like a single grain of sand on an endless beach. Hello, I am Theodore, the researcher. If you, like me, find a strange peace in confronting the terrifying scale of the universe, and if you wish to explore the mysteries that lie at the edge of human understanding, I invite you to subscribe to this channel. Together, we will journey into the dark, not to find answers that comfort us, but to find questions that expand us. Join us, and let us walk the path of discovery together. The object I am talking about is known as the Hercules Corona Borealis Great Wall. The name itself feels heavy, archaic, like something from a forgotten mythology. But this is not a myth. It is a superstructure of such staggering proportions that it breaks the ruler we use to measure the universe. To understand why this thing is so brutal to our understanding of reality, we first need to understand the scale we are used to. We need to recalibrate our minds to strip away the comfort of the familiar. Think of the Milky Way, our home. From one edge to the other, it spans roughly 100,000 light years. That number alone is hard to digest. Light, the fastest thing in the universe, traveling at 186,000 miles per second, takes 100,000 years just to cross our own backyard. If you were a photon of light born in a star at the edge of the Milky Way, you would have to travel for a time longer than the entire history of human civilization just to reach the center. You would pass billions of stars, each one a sun, each one a possible anchor for worlds we will never see. And yet, in the face of the Hercules Corona Borealis Great Wall, the Milky Way is nothing. It is a rounding error. It is invisible. The Great Wall is not measured in thousands of light years. It is not even measured in millions. This structure stretches for approximately 10 billion light years. Let that sink in. 10 billion light years. This is where the math becomes emotional. This is where the numbers stop being data and start being a source of existential vertigo. The universe itself, or at least the part of it we can see, is about 93 billion light years across. This single structure, this one continuous wall of gamma-ray bursts and galaxy clusters, takes up more than 10% of the diameter of the observable universe. It is not just a big object. It is a significant fraction of everything that is. If you could step back and look at the universe from the outside, you would not see a uniform mist of galaxies. You would see this colossal scar, this vein of matter dominance stretching across the dark. But why do I call it brutal? Why do I say it makes galaxies look like atoms? It is because of a concept known as the cosmological principle. For decades, modern astronomy has rested on a safe, comfortable assumption. We believed that if you zoomed out far enough, the universe was smooth. We believed that matter was distributed evenly, like butter spread over bread. We thought that, while there might be clusters of galaxies here and there were no structures larger than about 1.2 billion light years. That was the limit. That was the theoretical ceiling. Physics told us that gravity did not have enough time since the Big Bang to pull together anything bigger than that. And then we found the wall. It is nearly 10 times larger than the theoretical limit. It is a giant that has no business existing. It stands there in the deep past, mocking our equations. It suggests that matter did not just spread out evenly after the Big Bang, but that something else happened, something violent, ancient, and unknown, that clumped the universe together in ways we cannot yet explain. It tells us that our map of reality is fundamentally flawed. When we look at this wall, we are not just seeing a big group of galaxies. We are looking at a fossil from the dawn of time that refuses to fit into the history books we have written. Imagine for a moment that you are a traveler trying to cross this structure. You're in a spaceship that can move at the speed of light, a physical impossibility, but let us pretend for the sake of the journey. You enter one end of the Hercules Corona Borealis Great Wall. You fly past the first galaxy, a swirling island of 1 trillion stars. You fly past the second, the third, the millionth. You fly for 1,000 years. You have barely moved. You fly for 1,000,000 years. You are still at the starting line. You fly for 1 billion years. Enough time for life to evolve from single cells to dinosaurs and back to dust. And you are only 10% of the way through. To cross this single structure would take you almost the entire age of the universe itself. The silence of such a journey is absolute. In the void between the galaxy clusters that make up the wall, the emptiness is profound. There are vast stretches where matter is so thin that a cubic meter of space holds less than a single atom. And yet, this emptiness is part of the structure. It is the connective tissue of the giant. The wall is not a solid brick. It is a web, a filament, a chain of islands in the dark. But they are bound together. They are part of a whole. Gravity, that patient and infinite weaver, has tied them into a single destiny. When we call a galaxy an atom in this context, we are not being poetic. We are being literal in terms of scale. Just as an atom is a tiny, functional unit that builds up a mountain, a galaxy is merely the basic building block of this great wall. Our sun is an atom of an atom. Earth is an electron spinning around a nucleus that is itself invisible on the scale of the wall. And us? What are we? We are the dreamers living on the electron, looking up with our glass lenses, trying to comprehend the mountain. It is a humbling thought, isn't it? It strips away our ego. It reminds us that we are newcomers to a universe that was building monsters billions of years before the first carbon atom on Earth bonded to form life. The light we see from the Hercules Corona Borealis Great Wall left its source 10 billion years ago. Think about that time. 10 billion years. The Earth did not exist. The Sun did not exist. The Milky Way was likely just forming a chaotic mess of gas and young stars. When that light started its journey, the universe was a different place. It was younger, hotter, more violent. And that light has been traveling ever since. It has flown through the void while our solar system coalesced from dust. It has flown while the oceans formed. It has flown while life crawled from the sea to the land. It has flown while empires rose and fell. And finally, after 10 billion years of silence, that light hit the detectors of our satellites, carrying with it the secret of the wall. It is a ghost. We are looking at a ghost. We do not know what the wall looks like today. We only know what it looked like then, in the deep, ancient dark. This discovery forces us to ask questions that make us uncomfortable. If the universe can build something this big, what else is hiding in the parts of the sky we have not mapped yet? Are there structures even larger? Is the universe not a smooth sea, but a collection of gargantuan walls and voids, a foam of reality where we are trapped in one tiny bubble? The Hercules Corona Borealis Great Wall is not just a thing, it is a door. It is a door that is opened slightly, revealing a room so large that we cannot see the walls. As we stand here at the beginning of this series, I want you to let go of the need for easy answers. Science is not always about wrapping things up in a neat package. Sometimes science is about staring into the abyss and realizing the abyss is deeper than you thought. The existence of this wall challenges the standard model of cosmology. It challenges the Big Bang Theory's timeline. It challenges us, and that challenge is beautiful. It means the mystery is still alive. It means the map is still being drawn. In the chapters that follow, we are going to dissect this giant. We are going to look at how it was found, not with eyes, but with the screams of dying stars. We are going to look at the zone of avoidance, the part of our own galaxy that blocked our view for so long. We are going to explore the Great Attractor, the Sloan Great Wall, and the other titans that hinted at this discovery. But for now, just stay with the scale. Close your eyes for a second. Picture the night sky. Picture the stars. Now push them away. Push them until they are dust, and picture a wall of light, 10 billion years long, standing in the silence. That is where we are going. That is the reality we inhabit. The universe is not made for us. It is not built to human scale. It is built to the scale of gods and monsters. And yet, we are the ones perceiving it. We are the ones measuring it. In our smallness, there is a defiance. We refuse to be crushed by the size. We look up and we name the giant. We call it Hercules. We call it Corona Borealis. We wrap it in our words. And in doing so, we make it ours. This is the journey of the mind. This is the adventure of the soul. In the vast, silent theater of the cosmos, we are often deceived by the limitations of our own eyes. We evolved to see a tiny sliver of reality, a narrow band of the electromagnetic spectrum that we call visible light. We see the yellow warmth of the sun, the white twinkle of distant stars, the red glow of a dying ember. But the universe does not speak primarily in light that we can see. The universe screams in energies that would boil our blood and strip our atmosphere if we were not protected by the delicate envelope of our planet. The most profound structures in existence are often hidden in the dark, lurking in the wavelengths that pass right through us, invisible and cold. If we relied only on our eyes, the Hercules Corona Borealis Great Wall would have remained a ghost forever, a phantom giant standing right in front of us, unseen in the black between the stars. To find a monster of this magnitude, we could not simply look up and count the points of light. We had to wait for the universe to turn on a flashlight. We had to wait for the most violent events in creation to briefly illuminate the shadows. We had to listen for the death cries of the oldest stars. These events are called gamma-ray bursts, or GRBs. They are the most luminous electromagnetic events to occur in the universe since the Big Bang itself. To understand the Hercules Corona Borealis Great Wall, you must first understand the terrifying beauty of these bursts. Imagine a star far more massive than our sun, a star that has lived a short, furious life, burning through its nuclear fuel with a reckless intensity. When such a star dies, it does not go gently. Its core collapses under the crushing weight of its own gravity, imploding in a fraction of a second to form a black hole or a neutron star. This collapse is so violent that it drives jets of high-energy particles outward at nearly the speed of light, punching through the dying star's outer layers and blasting into the cosmos. For a few brief seconds, this dying star outshines the entire galaxy that hosts it. It releases more energy in a single moment than our sun will emit in its entire 10 billion-year lifetime. It is a cosmic flashbulb, a beacon of pure, blinding power that can be seen across the entire observable universe. These bursts are the lighthouses of the deep dark. They are the signal flares sent up by the cosmos, marking the location of matter in the vast void. Because these stars are short-lived and massive, they are always found in galaxies, usually in regions where star formation is active. Therefore, if you see a gamma-ray burst, you know there is a galaxy there. You know there is matter. You have a pin on the map. Hello, I am Theodore, the researcher. We are delving into the invisible architecture of our reality, peeling back the layers of the night to reveal the titans that have been hiding from us for billions of years. If you believe that the pursuit of knowledge is a form of meditation, and if you find peace in the realization of how vast the cosmos truly is, please take a moment to subscribe to this channel and join our community of explorers. Your presence here helps us continue this journey into the unknown, one discovery at a time. The discovery of the Great Wall did not happen because astronomers were looking for it. It happened because they were looking for patterns in these flashes of light. In the early 21st century, specifically around the year 2013, a team of astronomers led by Istvan Horvath was analyzing data from space telescopes that had been monitoring the sky for these bursts. Satellites like Swift and Fermi were our eyes in orbit, scanning the heavens, waiting for the invisible pulses of gamma radiation that signal a stellar cataclysm. These satellites are marvels of human engineering, silent sentinels watching the dark, recording the time, the direction, and the energy of every scream from the deep universe. The assumption, based on the standard theories of cosmology, was that these bursts should be distributed randomly. If the universe is truly smooth and homogeneous on large scales, as the cosmological principle states, then these explosions should pop off here and there, scattered evenly across the sky like raindrops falling on a pond. There should be no pattern. There should be no clustering. A burst here, a burst there, with no connection between them. But when Horvath and his team plotted the locations of these bursts on a map of the sky, they saw something that made them pause. They saw something that defied the randomness. In a specific region of the sky, covering the constellations of Hercules and Corona Borealis, there was a surplus, a cluster, a statistically significant grouping of gamma-ray bursts that could not be explained by chance. It was as if someone had taken a handful of sand and thrown it against a wall, and instead of scattering, the grains had all landed in a perfect line. These bursts were not close to us. They were incredibly distant, located at a redshift that corresponds to a distance of about 10 billion light years. But they were close to each other. They were clumped together in a way that suggested they were all part of the same massive underlying structure. This is the nature of astronomical detective work. We cannot touch the object. We cannot fly around it. We can only look at the shadows it casts or the lights it emits. In this case, the gamma-ray bursts were the lights outlining the shape of the monster. Just as city lights at night reveal the shape of a continent to an astronaut on the International Space Station, these stellar explosions revealed the shape of a filament of galaxies stretching across the universe. Because gamma-ray bursts are rare, happening only once every few million years in a typical galaxy, finding a cluster of them means there must be an enormous number of galaxies in that region to produce so many signals. Where there is smoke, there is fire, and where there are gamma-ray bursts, there is a massive concentration of matter. The structure revealed by these bursts was staggering. It spanned an angular size of nearly 100 degrees across the sky. To put that in perspective, the full moon is only half a degree wide. This thing covers a swath of the sky 200 times wider than the moon, but it is invisible to our eyes because it is so far away, and its light is so faint. But the gamma rays do not lie. They outlined a filament, a wall, a superstructure that measured roughly 10 billion light-years in length. It was a single bound entity of gas, dust, dark matter, and galaxies held together by gravity, floating in the epoch of the early universe. Think about the timing of this discovery. We found this structure by looking at light that is 10 billion years old. This means we are not seeing the Great Wall as it is today. We are seeing it as it was when the universe was only about 3 or 4 billion years old. We are looking at the universe's childhood, and in that childhood, we found a fully grown giant. This is the paradox that keeps astronomers awake at night. In the standard model of the Big Bang, the early universe was a hot, dense soup of particles. As it expanded and cooled, gravity began to pull matter together to form stars and galaxies. But gravity is a weak force. It takes time to work. It takes time to pull atoms together across vast distances. According to our simulations, by the time the universe was 3 billion years old, gravity should have only been able to build relatively small structures, galaxy clusters, perhaps a few 100 million light-years across. It should not have had enough time to organize matter into a wall 10 billion light-years long. It is like walking into a nursery and finding a teenager sitting in the crib. It simply does not fit the timeline. The existence of the Hercules Corona Borealis Great Wall suggests that something fundamental about our understanding of the early universe is incomplete. Perhaps gravity behaved differently back then. Perhaps dark matter, the invisible scaffolding of the cosmos, is more complex than we think. Or perhaps the universe did not start as smoothly as we believe. The emotional weight of this discovery is heavy. It forces us to confront our own ignorance. We built a model of the universe that was elegant, symmetrical, and understandable. We liked the cosmological principle because it made the universe predictable. It told us that no matter where you go, things are basically the same. But the Great Wall breaks that symmetry. It tells us that there are special places in the cosmos, places where matter has congregated in defiance of the average. It tells us that the universe is not a smooth sea, but a rugged terrain of mountains and canyons, and we are just a small boat drifting in the fog. When you look toward the constellations of Hercules and Corona Borealis tonight, You will see nothing but a few faint stars belonging to our own galaxy. You will see the darkness between them. But now you know that behind that darkness, deep in the well of time, lies the largest thing ever found, a structure so vast that it would take a beam of light nearly the age of the universe to traverse it. And we found it not by seeing the wall itself, but by seeing the momentary flashes of dying stars embedded within it. We found it by connecting the dots of cosmic violence to reveal a picture of cosmic order. There is a profound melancholy in this method of discovery. Every data point on Horvath's map, every dot that helped outline the Great Wall, represents the death of a star. It represents a catastrophic end, a supernova or a hypernova that destroyed a solar system. Perhaps there were planets orbiting those stars. Perhaps there were worlds that were vaporized in the blink of an eye when the gamma-ray jet erupted. We will never know. But their destruction was not in vain. Their final screams traveled across 10 billion years of void to reach us, to tell us, we are here. We are part of something greater. Do not forget us. In this way, the Hercules Corona Borealis Great Wall is a monument built from the ashes of the past. It is a testament to the cycles of creation and destruction that drive the cosmos. The stars die, but in their death, they illuminate the structure of the universe. They give us the map. We are the cartographers of the dark, reading the messages written in gamma radiation, piecing together the true shape of our home. And the shape that is emerging is far stranger, far larger, and far more mysterious than we ever dared to imagine. The scientific community was initially skeptical, and rightly so. Extraordinary claims require extraordinary evidence. The idea of a structure this size was so radical that many astronomers tried to dismiss it as a statistical fluke. They argued that perhaps the human brain was just seeing patterns where none existed, like seeing faces in the clouds. They argued that the sample size of gamma-ray bursts was too small to be certain. But as more data came in, as more satellites watched the sky, the pattern refused to disappear. The clump remained. The wall stood its ground. Other tests were performed. Other statistical analyses applied, and the probability of this being a random fluctuation dropped lower and lower. The wall is real. It is there. It is a brute fact of existence that we must integrate into our worldview. It sits there in the distance, a challenge to our intellect. It asks us, how did I form? What forces drove matter together on such a scale when the universe was so young? Was it the flow of dark energy? Was it cosmic strings? Was it some exotic physics from the first fraction of a second of the Big Bang that imprinted this pattern onto the fabric of space-time? We do not have the answers yet. We only have the discovery. This is the beauty of science. It is not a static book of facts. It is a living, breathing process of encountering the unknown. We thought we knew the limit of size in the universe. We thought we knew the rules of the game. And then the universe threw the Hercules Corona Borealis Great Wall at us, and we had to throw out the rule book. It reminds us that we are still children in the eyes of the cosmos. We have barely stepped out of our cradle. We have barely opened our eyes. As we continue this series, we will look deeper into the implications of this structure. We will ask what it would be like to live inside it. We will explore the other giants that challenge our understanding. But for this chapter, I want you to hold on to the image of the gamma-ray bursts. Think of them as flashlights turning on and off in a dark, cavernous room. You cannot see the walls of the room. You cannot see the floor or the ceiling. But every time a light flashes, you see a glimpse of something massive looming in the shadows. You see a texture, you see a shape, and slowly, flash by flash, death by death, the monster is revealed. We are mapping the body of God, or whatever name you choose to give to the totality of nature, with the light of dying suns. It is a poetic irony that destruction is the only reason we can see the construction. Without the violence of the gamma-ray bursts, the Hercules Corona Borealis Great Wall would be invisible to us. It would just be another empty patch of sky. Violence and silence, light and dark. These are the dualities that govern our exploration. So, the next time you feel overwhelmed by the noise of your daily life, remember the silence of the Great Wall. Remember that there are structures out there so big that they make our entire galaxy look like an atom. Remember that light has been traveling for 10 billion years just to bring us the news of its existence. And remember that we, with our short lives and our small brains, have managed to catch that light and understand what it means. We have looked into the dark and found the architecture of eternity. In the next chapter, we will confront the zone of avoidance, the blind spot in our own vision that hid the universe from us for so long, and how overcoming it paved the way for discoveries like the Great Wall. We will explore how our own home, the Milky Way, blocks our view of the greater cosmos, and the ingenuity required to look through the dust and stars of our own galaxy to see what lies beyond. The journey is far from over. The scale is only going to get more difficult to comprehend. Are you ready to keep walking into the dark? To understand the sheer magnitude of the Hercules Corona Borealis Great Wall? We must first understand the difficulty of seeing anything at all in a universe filled with obstacles. We tend to think of space as transparent, an endless, clear void where light travels unimpeded forever. But this is not true. Space is dirty. It is filled with dust, with gas, with magnetic fields, and with the blinding glare of foreground stars. For most of human history, our view of the cosmos has been obstructed not by the limits of our eyes, but by the very architecture of our home. We have been like a person trying to watch a distant mountain range while standing in the middle of a dense, foggy forest. The trees block the view. The fog scatters the light. We could see the sky above, but the horizon was lost to us. This obstruction has a name in astronomy. It is called the zone of avoidance. It sounds like a location from a science fiction novel, a place where spaceships are forbidden to go, but it is actually a region of our own sky. It is the band of the Milky Way itself. When you look up at night and see that beautiful, hazy river of light stretching across the heavens, you are looking into the dense disk of our own galaxy. You are seeing billions of stars, vast clouds of molecular hydrogen, and thick lanes of interstellar dust. To the naked eye, it is beautiful. To an astronomer trying to map the distant universe, it is a wall. It is a curtain drawn across 20% of the sky, hiding everything that lies behind it. Hello, I am Theodore, the researcher. We are continuing our quiet journey into the largest structures in existence, exploring how we map the infinite from our tiny, dust-choked corner of the galaxy. If you find value in understanding the limitations of our perspective and the ingenuity required to overcome them, please subscribe to this channel. Join us as we learn to see through the walls that nature has built around us. The zone of avoidance is the ultimate reminder of our provincialism. For centuries, astronomers simply ignored this part of the sky. They avoided it, hence the name. because they could not see through it. Optical telescopes, which rely on visible light, are useless against the thick dust clouds of the galactic plane. The dust absorbs the light from distant galaxies, making them invisible. Behind the bright band of the Milky Way, there could be monsters. There could be other great walls. There could be clusters of galaxies colliding in a chaotic dance of gravity. But for us, for the longest time, there was only the zone, a blank spot on the map, a region marked unknown. This matters because the Hercules Corona Borealis Great Wall challenges our understanding of how matter is distributed. But how can we be sure of any distribution if we are blind to 1/5 of the sky? How can we claim to know the shape of the universe when we cannot look out of our own window in all directions? The discovery of the Great Wall required us to transcend these limitations. It required us to stop looking with our eyes and start looking with physics. It required us to move beyond the visible spectrum. The universe does not stop existing just because we cannot see it. In the darkness behind the Milky Way, gravity is still working. Galaxies are still clustering. The great attractor, a gravitational anomaly that is pulling our own Milky Way and thousands of other galaxies towards it, was hidden in the zone of avoidance for decades. We knew something was pulling us. We could measure our own movement through space. We are racing towards something in the constellation Centaurus at over 1,000,000 miles per hour. But when we looked in that direction, we saw only the dust of our own galaxy. It was a cosmic mystery story where the culprit was hiding in plain sight, masked by the stars of our own neighborhood. It wasn't until the development of radio astronomy and infrared telescopes that we began to pierce the veil. Radio waves are long. They can slip around dust grains that would stop a photon of visible light dead in its tracks. Infrared light, which is essentially heat radiation, can burn through the cold dust, revealing the warm cores of galaxies hiding in the background. With these new eyes, the zone of avoidance began to dissolve. We started to find galaxies where we thought there was only emptiness. We found the great attractor. We found the Puppy's cluster. We found that the universe is continuous, that the web of matter does not stop at the edge of the Milky Way's disk. The discovery of the Hercules Corona Borealis Great Wall operates on a similar principle of overcoming blindness, but on a much grander scale. Remember, the Great Wall was found using gamma-ray bursts. These bursts are so powerful, so energetic, that they do not care about dust. They do not care about gas. A beam of gamma radiation from a dying star 10 billion light-years away can punch through almost anything. It slices through the intergalactic medium, passes through the halos of intervening galaxies, and arrives at our detectors with its message intact. By using gamma-ray bursts to map the cosmos, astronomers effectively sidestep the problem of the zone of avoidance and the problem of distance dimming. In optical astronomy, the further away something is, the harder it is to see. A galaxy at 10 billion light-years is a faint smudge, barely distinguishable from the background noise, even for the Hubble Space Telescope. But a gamma-ray burst, it is a spotlight. It is momentarily the brightest thing in the universe. It levels the playing field. It allows us to see the distant universe as clearly as the nearby universe. It removes the bias of distance. This is crucial because the Great Wall is not just big, it is deep. It sits at a redshift range of 1.6 to 2.1. In human terms, that is the deep past. It is a part of the universe that is usually shadowed by the sheer vastness of space and the expansion of the cosmos. Without the GRBs acting as beacons, we would never have seen the connection. We might have seen a few isolated faint galaxies, but we would never have connected the dots. We would have missed the forest because we were too focused on the individual dim trees. The psychological impact of the zone of avoidance and our subsequent victory over it is profound. It teaches us humility. It teaches us that darkness is often just a lack of the right kind of vision. When we say the universe is dark or empty, what we often mean is that we are blind. The Hercules Corona Borealis Great Wall was there all along. It was there when the Egyptians built the pyramids, shining its gamma rays down on the desert sand unseen. It was there when Galileo first pointed his glass tube at Jupiter, silent and invisible. It was there when Einstein wrote down the equations of general relativity, a solution waiting to be found. It existed in the unknown, not because it wasn't real, but because we hadn't learned how to look. Think of the patience required for this kind of science. The light from the Great Wall traveled for 10 billion years. It crossed the voids between superclusters. It navigated the gravitational lenses of massive galaxy groups. It arrived at Earth, and for most of human history, it passed right through us, unnoticed. It rained down on our heads, a cosmic whisper that we could not hear. It took the evolution of our species, the development of quantum mechanics, the launch of satellites like Swift and Fermi, and the dedicated analysis of researchers like Horvath to finally catch that whisper and turn it into a map. We are uncovering the skeleton of the universe. The visible galaxies, the beautiful spirals and ellipticals that we love to photograph, are just the skin. The Great Wall is the bone. It is the underlying structure around which the rest of the cosmos is draped. And this bone structure is massive. It suggests that the early universe was not a chaotic, random soup, but a place of early organization, a place where matter knew where to go. There is a concept in astronomy called the cosmic web. Simulations of the universe's evolution show that matter distributes itself in a web-like structure, long filaments of gas and galaxies separated by immense voids. The filaments are the highways of the universe, along which matter flows into the gravitational nodes where galaxy clusters form. The Hercules Corona Borealis Great Wall is likely one of these filaments, but on a scale that breaks the simulation. It is a superfilament, a thread of the web that is so thick and so long that it defies the algorithms we use to model cosmic growth. If the zone of avoidance was a curtain hiding the room next door, the discovery of the Great Wall is like realizing the house we live in is actually a cathedral. The scale has shifted. The walls are further away than we thought. The ceiling is higher, and the architecture is more ancient. We are no longer just mapping the local neighborhood. We are mapping the foundations of reality itself. As we look at the data from these GRBTs, we are also forced to confront the idea of our own isolation. We are inside a galaxy, the Milky Way, which is part of a local group, which is part of the Virgo supercluster, which is part of the Laniakea supercluster. We feel secure in this nesting doll of structures. But the Great Wall is a structure that dwarfs Laniakea. It makes our immeasurable supercluster look like a small suburb. If we lived inside the Hercules Corona Borealis Great Wall, our night sky would be very different. The density of galaxies would be higher. The rate of star formation might be different. The frequency of these terrifying gamma-ray bursts might be higher. We might not be here at all, because life requires stability, and the Great Wall, with its high density of exploding stars, might be a more dangerous place to live. Perhaps our location in a quieter, sparser part of the universe is a prerequisite for our existence. We live in the boondocks of the cosmos, far from the busy, violent highways of the major superstructures. And maybe that is why it took us so long to find them. We are the country mice discovering the big city for the first time. The lights are bright, the noise is loud, and the scale is overwhelming. In the next chapter, we will leave the zone of avoidance behind and dive into the cosmic web itself. We will explore how gravity weaves these massive structures, how the Great Wall connects to the rest of the universe, and why the voids, the empty spaces between the walls, are just as terrifying and important as the walls themselves. We will look at the architecture of nothingness. But for now, sit with this thought. The blockage is gone. The blindfold has been lifted. We have built eyes that can see through dust, ears that can hear radio waves, and detectors that can catch the screams of dying stars across time. The zone of avoidance is no longer a zone of ignorance. It is just another window. And through that window we see a universe that is vast, interconnected, and waiting for us. The silence is not empty. It is full. If you could step outside the universe, if you could float in the hyperdimensional emptiness that contains our reality and look down upon the cosmos like a god viewing a map, you would not see a random scattering of light. You would not see a chaotic spray of galaxies like spilled milk on a black table. Instead, you would see something that looks strikingly, hauntingly organic. You would see a web, a vast, glowing, three-dimensional latticework of filaments and knots stretching across the dark, looking for all the world like the neural network of a giant brain, or the delicate silk of a spiderweb glistening with morning dew. This is the cosmic web, the grandest architecture in nature, and the Hercules Corona Borealis Great Wall is the thickest, most massive strand in this infinite tapestry. The universe is not a collection of isolated islands. It is a single, continuous structure. The galaxies we see, the Milky Way, Andromeda, the distant spirals caught in our telescope lenses, are merely the pearls strung along invisible threads. They are the lighthouses built on the shores of invisible continents. To understand the Great Wall, we must understand the invisible architect that built it. We must talk about the ghost in the machine, dark matter. We cannot see dark matter. It does not emit light. It does not reflect light. It does not block light. It passes through our bodies and our planets as if we were made of mist. But we know it is there because of its gravity. It is the heavy hand that shaped the early universe. Hello, I am Theodore, the researcher. As we drift further into the structure of the cosmos, exploring the skeleton of reality itself, I invite you to settle in. Let the scale of these concepts wash over you, not as a source of anxiety, but as a reminder of the magnificent complexity we are part of. If you enjoy these journeys into the deep architecture of the universe, please subscribe to this channel. Join us as we trace the invisible threads that bind the galaxies together. In the beginning, mere moments after the Big Bang, the universe was almost perfectly smooth. It was a hot, dense soup of particles. But it was not perfectly smooth. There were tiny, microscopic fluctuations, ripples in the density of the cosmos. These were the seeds. As the universe expanded and cooled, dark matter began to pool in these slightly denser regions. Gravity, the patient sculptor of the void, began its work. It pulled slowly over millions and then billions of years. The dark matter collapsed into long filaments, sheets, and massive halos. It built a scaffold. It built a skeleton. And then normal matter, the hydrogen gas that makes up stars and you and me, flowed into this skeleton like water flowing into a riverbed. The galaxies lit up inside these dark matter filaments. They formed along the lines of the web. Where 2 or 3 filaments crossed, massive clusters of galaxies formed, like the intersections of cosmic highways. This is the cosmic web, and the Hercules Corona Borealis Great Wall is a superfilament. It is a region where the web is so dense, so thick with matter, that it forms a continuous structure over 10 billion light-years long. It is a spine of the universe. To look at the Great Wall is to look at the masterwork of gravity over deep time. It is to see where the river of the cosmos runs deepest and strongest. But a web is not defined only by its strands. It is also defined by the empty spaces between them. For every mountain, there must be a valley. For every wall, there must be a void. The discovery of the Great Wall also highlights the terror and the beauty of the cosmic voids. These are the vast spherical regions of emptiness that sit between the filaments of the web. They are the deserts of the universe. If the Great Wall is a bustling metropolis of galaxies, the voids are the desolate oceans where nothing exists for hundreds of millions of light years. Imagine being a traveler in one of these voids, the Boots void, for example, or the Eridanus supervoid. If you were floating in the center of one of these empty bubbles, you would see almost nothing. The galaxies that make up the walls of the web would be so far away that they would be too faint to see with the naked eye. You would be surrounded by absolute, crushing blackness, a silence deeper than any silence on earth. You would be truly alone, drifting in a region of space where matter has been evacuated, pulled away by the greedy gravity of the surrounding walls. The voids are expanding, pushing the filaments of the web closer together, squeezing the galaxies into tighter and tighter lines. The Hercules Corona Borealis Great Wall exists because the voids around it are so vast. It is the accumulation of matter that has been stripped from the empty regions. It is the survivor of the cosmic game of tug-of-war. Gravity pulls matter in. Dark energy pushes space out. The wall is the victory of gravity. It is a fortress of mass standing against the expansion of the void. When we map the Great Wall using those gamma-ray bursts we discussed, we are effectively tracing the boundary between the something and the nothing. We are walking the coastline of existence. This interplay between the wall and the void creates a picture of the universe that is dynamic, almost alive. The gas in the universe flows. It moves along the filaments of the cosmic web like blood in a vein, feeding the galaxies, fueling star formation. The Great Wall is a place where this flow is torrential. It is a region of high traffic, a place where galaxies are constantly colliding, merging, and growing. This is likely why it is so full of gamma-ray bursts. The violence of the wall is a symptom of its vitality. It is a place of birth and death on a scale we can barely comprehend. But here is where the size of the Great Wall becomes a problem for our science. The cosmic web theory predicts that structures should grow over time. Gravity takes time to pull things together. As I mentioned before, the standard model suggests that a structure 10 billion light-years long simply shouldn't have had time to form by the time we see it. It is too big, too early. It is like finding a fully built skyscraper in a city that was founded yesterday. This suggests that the seeds of the cosmic web, those tiny fluctuations in the early universe, must have been different than we thought. Perhaps there were primordial waves of density, vast ripples in the fabric of space-time itself that laid the foundation for the Great Wall long before the first star ignited. We call these baryonic acoustic oscillations, sound waves from the Big Bang that froze into the distribution of matter. The Great Wall might be the frozen echo of a sound that rang out when the universe was less than 400,000 years old. Imagine that, a sound so loud, so deep, that it created a wall of galaxies 10 billion light-years long. We are looking at the visual representation of the universe's first song. When we consider the Hercules Corona Borealis Great Wall as a part of this web, we also have to reconsider our own place. The Milky Way is part of a filament too. We are part of the Laniakea supercluster, which is a leaf on a branch of a much larger tree. We are connected to the Great Wall. The gravity of that distant giant is tugging on us, ever so slightly. The web is continuous. If you could pluck the filament that contains the Great Wall, the vibration would travel down the strands, across the billions of light years, and eventually, imperceptibly, shake the Milky Way. We are physically connected to that monster in the dark. The metaphor of the brain is one that astronomers and philosophers often return to. When we run computer simulations of the cosmic web, like the famous Millennium Run simulation, the resulting images look uncannily like the neurons in a human brain. The filaments are the axons. The galaxy clusters are the cell bodies. The electrical signals are the flow of gravity and light. Is it just a coincidence? Is it just that nature tends to find the most efficient structures, whether at the scale of a micrometer or a gigaparsec? Probably. But it is a poetic coincidence that brings a sense of wonder. If the universe looks like a brain, then the Hercules Corona Borealis Great Wall is a major neural pathway. It is a thick bundle of nerves carrying the history of the cosmos. And what are we? We are the thoughts. We are the fleeting moments of consciousness sparking inside one of the atoms of this colossal mind. It is a romantic idea, perhaps not strictly scientific, but it captures the feeling of integration. We are not separate from the web. We are made of it. We are the web waking up and looking at itself. The brutality of the Great Wall, then, is not just in its size, but in its dominance. It shows us that the universe is not a democracy of matter. It is an aristocracy. Most of the universe is empty void. The wealth of the cosmos, the stars, the gas, the life, is concentrated in these thin, fragile filaments. We live in the privileged 1% of space, where existence is possible. The Great Wall is the capital city of this aristocracy. It is where the action is. It is where the story of the universe is being written most aggressively. As we look at this structure, we must also think about the future. The cosmic web is not static. It is stretching. Dark energy is pulling the universe apart. The voids are getting bigger. The filaments are getting thinner. Over hundreds of billions of years, the web will snap. The clusters will become isolated islands, cut off from the rest of the cosmos by the expanding dark. The Hercules Corona Borealis Great Wall, because of its immense gravity, might hold together longer than most. It might become one of the last strongholds of structure in a dying universe. A fortress that refuses to fall, but that is a tragedy for the far future. For now, we live in the golden age of structure. We live in a time when we can see the web, when we can map the walls, when we can connect the dots. The Great Wall is a challenge, yes. It breaks our models, yes. But it is also a gift. It is a laboratory for studying gravity at the most extreme scales imaginable. It allows us to test Einstein's theories across distances that defy logic. In the silence of your own room, try to visualize this web. Close your eyes and see the darkness. Then see the thin, glowing lines of silver threading through the dark. See the knots where the lines meet. See the vast empty bubbles of the voids. And then see the great wall, a scar of brilliance, a thick rope of diamond dust stretching across the entire vision. That is the real world. That is the true map. The Earth, the Sun, the solar system, these are just microscopic details, invisible specks on one of those silver threads. The realization that we live in a web changes how we feel about space. It is no longer just outer space, a place of separation. It is connective space. The gravity that holds your feet to the ground is the same force that binds the Great Wall together. The atoms in your body follow the same laws as the gas flowing along those cosmic filaments. We are small, yes, but we are woven into the grandest tapestry of all. In the next chapter, we will confront the standard model of cosmology, the set of rules we thought governed the universe, and how the Great Wall threatens to tear it down. We will explore the crisis in modern physics, the tension between what we calculate and what we observe, and the possibility that we might need a new physics to explain the giant in the north. The wall is not just a structure, it is a question mark burned into the sky. Are you ready to question the laws of nature? We build castles in the sky, not out of stone, but out of mathematics. For the last century, humanity has constructed a grand edifice of equations and theories designed to explain everything from the smallest subatomic particle to the largest supercluster. We call this the standard model of cosmology, or more technically, the lambda CDM model. It is our best attempt to write the biography of the universe. It tells a story of a big bang, of rapid inflation, of a smooth, cooling cosmos where gravity gently pulled matter into the galaxies we see today. It is a beautiful story. It is elegant. It makes sense. It gives us a feeling of control, a sense that we have tamed the chaos of existence with the power of our minds. But there is a problem with castles built in the sky. Sometimes reality sends a storm that tears them down. The Hercules Corona Borealis Great Wall is that storm. It is the anomaly that refuses to be silenced, the data point that screams at us that our beautiful model might be fundamentally broken. The standard model rests on a foundation known as the cosmological principle. This is not just a scientific rule, it is a philosophical statement. It says that the universe is isotropic and homogeneous. In simple terms, it means that the universe looks the same in every direction and that, on a large enough scale, matter is spread out evenly. Imagine a vast ocean. If you look at a cup of water, it is chaotic, bubbles, currents, debris. But if you look at the ocean from space, it is a smooth, uniform blue. The cosmological principle tells us that the universe is like that ocean. If you zoom out far enough, beyond the scale of individual galaxies or even clusters, everything should smooth out. There should be no special places, no unique structures, no giants. Hello, I am Theodore, the researcher. We are standing at the edge of scientific certainty, looking into a void that defies our laws. If you are brave enough to question the very foundations of what we think we know, and if you find wonder in the moment when a mystery deepens rather than resolves, please subscribe to this channel. Join us as we explore the cracks in the walls of our knowledge. Based on the cosmological principle and the known age of the universe, about 13.8 billion years, physicists have calculated a theoretical limit for how big cosmic structures can get. That limit is roughly 1.2 billion light-years. According to our understanding of gravity and the speed of light, there simply hasn't been enough time since the Big Bang for anything larger to form. Gravity is a slow worker. It takes billions of years to pull matter across vast distances. To build a structure larger than 1.2 billion light-years would require forces we do not understand or time we do not have. It is a speed limit on the growth of the cosmos. And then we found the Great Wall, 10 billion light-years across. It is not just slightly above the limit. It is nearly 10 times larger than the maximum size allowed by our physics. It is a statistical impossibility. It is like finding a human being who is 50 feet tall. It shouldn't happen. It cannot happen. And yet, there it is. The existence of the Hercules Corona Borealis Great Wall suggests that the universe is not homogeneous. It suggests that, on the largest scales, the ocean is not smooth at all. It is filled with tsunamis and trenches that dwarf our imagination. This brings us to a crisis in modern cosmology. When observation contradicts theory, one of them has to give way. Usually we check the observation. We assume we made a mistake. Maybe the gamma-ray bursts aren't really clustered. Maybe it is a trick of the data. But as I mentioned before, the data holds up. The wall is real. So we are left with the terrifying and exhilarating possibility that the theory is wrong. The lambda CDM model, for all its success in explaining the cosmic microwave background and the abundance of elements, might be missing a massive piece of the puzzle. What could that piece be? Some physicists speculate that we need to rethink gravity itself. Perhaps on these titanic scales, gravity does not behave as Einstein predicted. Maybe it is stronger, capable of pulling matter together faster than we thought possible. Or perhaps dark energy, the mysterious force accelerating the expansion of the universe, is not a constant. Maybe it changes over time, and in the early universe, it behaved in a way that allowed for the rapid formation of these superstructures. We are talking about new physics, laws of nature that we have not yet discovered, hiding in the sheer scale of the Great Wall. There is another possibility, one that is even more unsettling. It involves the very beginning of time. The standard theory of inflation suggests that the universe expanded exponentially in the first fraction of a second, smoothing out any wrinkles. But what if the bang wasn't uniform? What if the universe was born with a limp? What if there were primordial giant fluctuations, huge concentrations of energy that were baked into the cosmos from the very first moment? If that is true, then the Hercules Corona Borealis Great Wall is a scar from the birth of the universe. It is a direct link to the conditions of the Big Bang, a fossil of the initial chaos that created us. This creates a feeling of vertigo. We look at our equations, written in chalk on dusty blackboards, and we feel safe. E equals mc squared. F equals g m1 m2 over r squared. They are clean. They are precise. But nature is not clean. Nature is messy. Nature builds walls 10 billion light-years long just to show us that we don't know everything. The Great Wall is a reminder that the map is not the territory. We have drawn a map of a smooth, simple universe, but we are walking through a landscape of giants. The term end of greatness is used by astronomers to describe the scale at which structure disappears and the universe becomes smooth. We thought we had reached the end of greatness. We thought we understood the texture of reality. But the Hercules Corona Borealis Great Wall tells us that greatness does not end. The structures just keep getting bigger, and our minds just keep getting smaller in comparison. It is a humbling realization. We are not the masters of the universe. We are merely observers trying to guess the rules of a game that is being played on a board larger than we can see. To accept the Great Wall is to accept that we might be wrong about everything, or at least wrong about the big picture. It means that the textbooks of the future will look very different from the textbooks of today. It means that there is work to be done. For a scientist, there is no greater joy than being proven wrong, because being wrong means there is something new to find. It means the mystery is still alive. The Great Wall is not a dead end. It is a doorway. It invites us to throw away our assumptions and look at the universe with fresh eyes. Imagine the universe as a grand symphony. The standard model tells us the tempo and the key. It tells us which instruments are playing. But then, suddenly, in the middle of the performance, we hear a note that doesn't belong. A deep, resonant bass note that shakes the floorboards. That note is the Great Wall. It doesn't fit the sheet music we have written. Does that mean the orchestra is playing it wrong? No, it means we are listening to a song we haven't learned yet. It means the composer, nature itself, is far more creative than we are. The tension between what we see and what we expect is the engine of science. Without anomalies like the Great Wall, we would stagnate. We would become complacent. We would think we had solved the puzzle. But the universe is kind enough to keep breaking our puzzles. It breaks them so that we have to put them back together in new, more complex ways. The Hercules Corona Borealis Great Wall is a gift of confusion. It forces us to grow. As you sit there, perhaps in a room lit by the soft glow of a screen, consider the fragility of knowledge. Everything we think we know about the cosmos is based on the light that happens to reach Earth. We build models based on that light. But what if the light is telling us a story we don't know how to translate? What if the rules of physics are just local guidelines, valid here in our quiet suburb, but useless in the chaotic downtown of the Great Wall? The thought is dizzying. It is the kind of thought that makes you feel the floor drop out from under you. But let that feeling be a comfort. It means the world is not small. It means the universe is not boring. It means that no matter how much we learn, there will always be a great wall waiting in the dark to surprise us. There will always be a frontier. And as long as there is a frontier, the human spirit has a place to go. We are explorers by nature, and the universe has just given us a new continent to map. In the next chapter, we will shift our gaze from the physics of the wall to the philosophy of the wall. We will ask what it would mean for a civilization to evolve inside such a structure. Would they know they were part of a giant? Would their sky be brighter, their nights more dangerous? We will explore the hypothetical life of the wall and how our own isolation shapes our philosophy. The journey into the mind of the giant continues. Imagine waking up on a world where the night does not exist, or rather, where the night is not a curtain of black velvet punctuated by lonely points of light, but a glowing, shifting tapestry of fog and fire. Here on earth, we are used to the dark. We are used to looking up and seeing the vast, empty spaces between the stars. We feel the cold of the void pressing down on us. But what if you were born on a planet nestled deep within one of the dense galaxy clusters that make up the Hercules Corona Borealis Great Wall? What if your home was not in the quiet suburbs of the universe, but in the bustling, chaotic downtown of the largest city in existence? Your sky would be a masterpiece of cosmic violence. It would be crowded. It would be loud with light. In the regions of space we inhabit, galaxies are separated by millions of light years. The Andromeda Galaxy, our nearest large neighbor, is a faint smudge that you need a dark sky and good eyes to see. But inside the filaments of the Great Wall, The density of matter is far higher. Galaxies are packed together like sardines in a tin. If you stood on a planet in the core of this structure, you might see a dozen grand spiral galaxies hanging in your sky, each one as large and detailed as the full moon. You would see the bridges of stars connecting them, the tidal tails ripped out by gravity, the glowing gas of the intergalactic medium. You would not need a telescope to understand the structure of the universe. You would simply need to look up. The cosmic web would not be a theoretical computer simulation to you. It would be the ceiling of your house. Hello, I am Theodore, the researcher. We are engaging in a thought experiment of cosmic proportions, shifting our perspective from the cold equations of physics to the warm, terrifying possibility of life inside the giant. If you want to explore not just the universe as it is, but the universe as it could be experienced by other eyes, please subscribe to this channel. Join us as we imagine the view from the inside of the Hercules Corona Borealis Great Wall. The beauty of such a sky would be matched only by its terror. We must remember how we found this great wall. We found it by detecting gamma-ray bursts, the screams of dying stars. We found it because this region of space is a hotbed of stellar cataclysm. A civilization evolving inside the Great Wall would be living in a shooting gallery. In our quiet corner of the Milky Way, a gamma-ray burst is a rare, theoretical danger. We worry about an asteroid hitting Earth every few million years. But inside the wall, where star formation is driven by constant galactic mergers and interactions, the rate of these explosions would be significantly higher. Imagine a civilization that has to build its cities underground, not because of weather or war, but because the sky itself is radioactive. Every few thousand years, a star in a nearby galaxy collapses, sending a beam of gamma radiation slicing through the system. If that beam hits a planet, it can strip the ozone layer in seconds, exposing the surface to lethal ultraviolet radiation from its own sun. The beings of the wall might look at the stars not with wonder, but with suspicion. They might view the cosmos as a hostile, volatile beast that must be watched constantly. Their astronomy would not be a hobby. It would be a survival strategy. They would be the ultimate preppers, listening to the ticking clocks of millions of massive stars waiting for the flash. This environment would shape their philosophy in profound ways. We humans often feel insignificant because of the emptiness around us. We feel small because the universe seems vast and indifferent. But a species in the Great Wall might feel insignificant for a different reason. They are crushed by the crowd. They are not alone. They are too connected. They would see, with their naked eyes, that galaxies collide and consume each other. They would witness the brutal reality of galactic cannibalism on a nightly basis. They would see large galaxies tearing smaller ones apart, stripping their stars and gas, absorbing them into their own mass. The violence of gravity would be the central myth of their culture. Here on Earth, we tell stories of the music of the spheres, a harmonious, orderly cosmos. Inside the Great Wall, the mythology might be one of the war of the spheres. They would see the chaos of elliptical galaxies forming from the wreckage of spirals. They would see the loss of structure, the blending of stars into smooth, featureless blobs. To them, the universe might not look like a clockwork mechanism, but like a storm that has been raging for billions of years and shows no sign of stopping. This constant visual reminder of destruction might make them deeply fatalistic, or perhaps incredibly resilient. They would know, with a certainty we cannot possess, that nothing lasts, not even galaxies. But let us flip the coin. What about the potential for connection? In our part of the universe, the idea of intergalactic travel is a joke. It is a fantasy. To reach Andromeda would take millions of years, but in the dense knots of the Great Wall, the distance between galaxies can be much smaller. It is still vast, yes, but perhaps bridgeable. If civilizations arose in neighboring galaxies within the wall, they might be able to detect each other. They might be able to send signals. The time delay would still be thousands of years, but that is a blink of an eye compared to the silence we face. The Great Wall could be the home of the first intergalactic federation, not in the way we see in movies with spaceships zipping back and forth, but a federation of knowledge, a network of civilizations separated by a sea of stars, but united by the ability to see one another. Imagine a culture that has received a radio message from a galaxy visible in their day sky. They cannot reply in time for the sender to hear it, but they can listen, they can learn, they can download the encyclopedia of a dead world. The Great Wall might be the repository of the greatest library in the cosmos, a place where information flows along the filaments of the web, carried by light and radio waves from one island to another. The sheer amount of matter in the Great Wall also implies a staggering number of stars. We are talking about billions of galaxies, each containing hundreds of billions of stars. The number of planets in such a structure is beyond human comprehension. It is a number so large that, if you wrote it out, the zeros would fill a book. If life is a game of probability, then the Great Wall is the casino where the house always wins. Life must exist there. It is statistically impossible for it not to. And given the age of the structure, remember, we see it as it was 10 billion years ago, that life has had a long time to evolve. Or has it? This brings us back to the paradox of the wall's age. If the structure is so old, formed so soon after the Big Bang, the first generations of stars would have been metal poor. They would have lacked the carbon, oxygen, and iron needed to build planets and bodies. The first civilizations in the Great Wall would have had to wait. They would have had to wait for the first waves of supernovas to enrich the gas, to scatter the heavy elements across the cosmos. The gamma-ray bursts that we fear would have been the very engines creating the building blocks of life. Destruction and creation, locked in an embrace. The beings of the Great Wall would likely be made of star stuff, just as we are. They would be carbon-based, water-dependent, looking up at a sky that gave them birth. But their star stuff might be mixed differently. In a region of such high density, the chemical enrichment of the universe happens faster. The gas clouds are polluted with heavy elements more quickly. It is possible that planets formed earlier in the Great Wall than they did in the Milky Way. It is possible that we are the latecomers, the rustics evolving in the backcountry long after the metropolises of the Wall had already risen and fallen. Consider the concept of the night. On a planet deep inside a cluster in the Wall, the combined light of billions of nearby stars and galaxies might create a perpetual twilight. True darkness might be unknown. This would affect everything from their sleep cycles to their religion. They might worship the light not as a savior, but as a tyrant. They might long for the dark. They might build great observatories with shields to block out the galactic glare, just to catch a glimpse of the deep universe beyond. And what would they see if they looked out? If they looked away from the plane of the Great Wall, they would see the voids. They would see the terrifying emptiness of the Boots Void, or its cousins. To them, the universe would look like a sandwich, a thick, blindingly bright layer of galaxies where they live. sandwiched between two infinite abysses of nothingness. This would reinforce their sense of precariousness. We are the survivors on the raft, they might say. Beyond our shores, there is only death and cold. Their cosmology would be centered on the wall. The wall would be their entire world, the only place where existence is permitted. We, on the other hand, live in a more ambiguous region. We are not in a void, but we are not in a great wall. We are in a filament, a small thread. We see both the darkness and the light. We have a balanced view. Perhaps this balance is necessary for us to understand the universe as a whole. A being inside the Great Wall might be too blinded by its own environment to see the big picture. They might think the whole universe is dense and crowded. They might not discover the expansion of the universe as easily as we did, because the local gravity of the wall is so strong that it overpowers the cosmic expansion in their immediate vicinity. The zone of avoidance we discussed in the previous chapter was a barrier of dust, but for a civilization in the Great Wall, the barrier would be the light itself. The glare of 1 trillion stars would act as a fog, hiding the faint signals of the early universe. We were able to discover the cosmic microwave background, the afterglow of the Big Bang, because our sky is relatively quiet. Would they be able to hear that whisper over the roar of their own galaxy cluster? Or would they be deaf to the origins of time, trapped in a loud, bright present? This thought experiment teaches us that our location in the universe is a privilege. We often complain about being stuck on a pale blue dot in the middle of nowhere. But this nowhere is a vantage point. It is a clear, quiet hill from which we can survey the entire landscape. The Hercules Corona Borealis Great Wall is a magnificent place, a cathedral of light, but it might be a terrible place to do astronomy. It might be a place where the grandeur of the local environment blinds you to the subtle truths of the cosmos. As we imagine these hypothetical beings, we can feel a strange kinship with them. We are both trapped in our own perspectives. We are both trying to map a room we cannot leave. They look out from their fortress of light and wonder about the dark. We look out from our dark quietude and wonder about the light. The gamma-ray burst that traveled 10 billion years to reach us was a message from their world to ours. It was a shout across the void. We cannot answer, but we can hear it. And what if they are looking back? What if, in one of those elliptical galaxies in the wall, a civilization has built a telescope powerful enough to see the Milky Way? To them, we would be a faint, uninteresting speck on the edge of a void. We would be the zone of avoidance. They might not even catalog us. We would be below the threshold of interest. This is the final indignity of the Great Wall. It makes us realize that, to the giants, we are not even ants. We are bacteria. But bacteria have a way of surviving. Bacteria have a way of adapting. And in our case, the bacteria have learned to calculate the mass of the giant. We have learned to weigh the wall. We have learned to measure its distance. There is a power in that, a power that transcends size. The mind is the only thing in the universe that can contain the Great Wall without breaking. When you hold the concept of 10 billion light years in your head, you are, in a moment of pure cognition, larger than the thing you are thinking about. In the next chapter, we will pull back from the Hercules Corona Borealis Great Wall to look at its rivals. Is it truly the biggest? We will discuss the Sloan Great Wall, the Boss Great Wall, and the terrifying gravitational anomaly known as the Great Attractor. We will place our giant in a lineup of monsters to see how it compares. We will ask if there is a limit to how big things can get, or if we are just seeing the tip of the iceberg. The zoo of cosmic titans is open, and we are just getting started. In the grand gallery of cosmic architecture, the Hercules Corona Borealis Great Wall is the undisputed titan, but it does not stand alone. To truly appreciate its brutal scale, we must place it in a lineup of the other monsters we have discovered, the rival structures that once held the title of largest in the universe, before this giant was revealed. Throughout our journey as explorers of the deep dark, we have found that every time we think we have reached the limit of how big things can get, the universe pulls back another curtain to show us something even more staggering. We are like cartographers who keep finding new continents in a sea we thought we had already mapped. Before the discovery of the Hercules Corona Borealis Great Wall, the crown belonged to the Sloan Great Wall. Discovered in 2003, this structure was a massive filament of galaxies stretching about 1.37 billion light-years across. At the time, it was considered a rule breaker, pushing the absolute limits of the cosmological principle. It was a monumental discovery that changed our understanding of the cosmic web. But compared to our current giant, the Sloan Great Wall is nearly 10 times smaller. If the Hercules Corona Borealis Great Wall is a sprawling metropolis, the Sloan Great Wall is merely a large city. Hello, I am Theodore, the researcher. We are comparing the heavyweights of the cosmos, looking at the hierarchy of structures that lead up to the absolute limit of what we have found. If you find a quiet thrill in seeing how our perspective has expanded with every new discovery, please subscribe to this channel. Join us as we walk through the zoo of cosmic titans. Then, there is the Boss Great Wall, discovered in 2016. This gargantuan collection of over 800 galaxies stretches for about 1 billion light-years and is even more massive than the Sloan Great Wall in terms of total matter. It is a dense, heavy knot in the fabric of space. Yet, even this boss of the universe is dwarfed by the sheer linear extent of the Hercules Corona Borealis Great Wall, which reaches across 10 billion light-years of the observable universe. We must also mention the Great Attractor, a mysterious gravitational anomaly lurking in the zone of avoidance. While not a wall of galaxies, it is a region of space so massive that it is pulling our own Milky Way and thousands of other galaxies towards it at speeds of over 1.4 million miles per hour. It is a gravitational drain at the center of our local supercluster, Laniakea. But even Laniakea, which contains 100,000 galaxies and spans 500 million light-years, is just a small neighborhood compared to the continent-sized structure of the Great Wall. This raises a fascinating question. Is there an end to this? Does the greatness eventually stop? Some astronomers point to even more exotic structures like the giant GRB ring, a circle of 9 gamma-ray bursts that spans nearly 5.6 billion light-years, or the Large Quasar Group, a cluster of 73 quasars that stretches 4 billion light-years across. Each of these discoveries acts as a challenge to the standard model we discussed, suggesting that the early universe was far more structured and clumpy than our smooth equations allow. The Hercules Corona Borealis Great Wall remains the champion because it represents the most extreme concentration of matter we have ever confirmed. It is the upper limit. It sits at the very edge of what physics says is possible in the time since the Big Bang. When we compare these structures, we realize that we aren't just looking at big things. We are looking at the different ways gravity can organize reality. Some structures are dense and heavy, like the boss wall. Others are long and spindly, like the Great Wall. Others are gravitational magnets, like the Great Attractor. As we place the Hercules Corona Borealis Great Wall at the top of this list, we must consider the brutality of its position. It makes galaxies look like atoms, not just because of its size, but because it redefined the scale of the entire game. Before its discovery, we thought we were looking at the whole board. Now, we realize we were just looking at one square. The universe is not a series of small, isolated events. It is a vast, interconnected machine where structures are built upon structures, and the Great Wall is the main chassis. In the quiet of our own solar system, these comparisons can feel abstract. But imagine the map of the universe as a vast tapestry. If the Milky Way is a single thread, and a supercluster is a patch of color, the Hercules Corona Borealis Great Wall is the loom itself. It is the framework that allows the rest of the tapestry to exist. The existence of such rivals only makes the Great Wall more impressive. It has survived every attempt to find something bigger. It stands as a monument to the first few moments of creation, when the density of the universe was decided. It is a reminder that no matter how much we think we know about the giants of the cosmos, there is always a bigger monster lurking in the dark. In the next chapter, we will discuss the end of the era of starlight and what will become of these massive structures in the far, far future. What happens when a structure 10 billion light-years long begins to fade? We will explore the heat death of the universe and the final fate of the Great Wall. The story is moving toward its sunset. Are you ready for the long dark? Everything that has a beginning must also have an end. And the Hercules Corona Borealis Great Wall, for all its brutal and terrifying scale, is no exception. We are currently living in a brief, brilliant window of cosmic history, the era of starlight. It is a time when the universe is vibrant, messy, and filled with organized complexity, like the Great Wall. But as we look forward into the deep future, we see a timeline that makes the 10 billion year journey of light from the wall seem like a single heartbeat. We are moving toward a universe that is cold, lonely, and eventually completely empty. Hello, I am Theodore, the researcher. We are approaching the final horizon of our journey, looking past the current majesty of the Great Wall to see the inevitable silence that awaits it. If you find a strange, melancholic peace in understanding the ultimate fate of all things, please subscribe to this channel. Join us as we witness the sunset of the giants. The first stage of the wall's decline is already underway, the exhaustion of fuel. Like the massive elliptical galaxy IC 1101, which sits at the heart of a cluster and has used up its gas, the Hercules Corona Borealis Great Wall will eventually stop creating new stars. The era of birth will give way to an era of aging. The massive blue giants within the wall's galaxies will explode and disappear. The sun-like stars will swell into red giants and then fade into white dwarfs. Eventually, only the small, dim red dwarfs will remain, flickering like the last embers of a dying fire for trillions of years. But as the stars go out, the structure itself will face a different enemy: dark energy. Right now, gravity is the king of the Great Wall, holding 10 billion light-years of matter together in a single, bound structure. But space itself is expanding, and that expansion is accelerating. Over the next 100 billion years, the cosmic web will begin to fray. The vast voids we discussed will grow larger and more aggressive, pushing the filaments apart. Even a structure as massive as the Hercules Corona Borealis Great Wall cannot survive this forever. Eventually, the expansion of space will become so fast that light from one end of the wall will no longer be able to reach the other. The structure will vanish behind a cosmic horizon. It will be torn apart, not by violence, but by the stretching of reality itself. The galaxies that once made up the wall will become isolated islands, drifting in an infinite empty ocean, unable to see any other light in the sky. In the very long run, measured in years with so many zeros they would fill pages, even the remnants of the wall will dissolve. The black holes at the centers of its galaxies, monsters with billions of times the mass of our sun, will slowly evaporate through Hawking radiation. The matter that once formed the brutal spine of the universe will decay into subatomic particles and radiation, spreading out until the density of the universe is nearly zero. This is the heat death of the universe, the ultimate silence. There is a profound beauty in this inevitable end. The fact that something as large as the Great Wall can exist for a time, even if that time is finite, is a testament to the creative power of the laws of physics. We are lucky to exist now, during this flowering of complexity, when we can still see the giants. We are the witnesses to the universe's most magnificent era. As we conclude this chapter, I want you to remember that while the Great Wall will eventually fade, the fact that we discovered it remains. We, the star stuff that woke up for a brief moment, have successfully mapped the skeleton of eternity. We have looked into the deep dark and found that it was not empty, but filled with a grand, ancient architecture. In the final chapter, we will wrap up our journey with Theodore, the researcher, reflecting on what the Hercules Corona Borealis Great Wall teaches us about our own lives and the legacy of human curiosity. We will return home from the edge of the universe, changed by the scale of what we have seen. As we return from the edges of the 10 billion light-year void, we find ourselves back on our small, rocky world. But we are not the same. We have looked upon the Hercules Corona Borealis Great Wall and realized that we inhabit a universe where galaxies are merely atoms, the basic building blocks of a brutal and magnificent skeleton. This structure, which stretches across more than 10% of the observable universe, serves as a final reminder of the scale of our reality. It tells us that the cosmos is not a series of isolated events, but a single, interconnected tapestry of matter and energy. Hello, I am Theodore, the researcher. We have reached the end of our journey into the largest known structure in existence. If this exploration of the Great Wall has expanded your perspective and offered you a moment of cosmic peace, please subscribe to this channel and share your thoughts in the comments. Your curiosity is the bridge between our small world and the infinite dark. The discovery of the Great Wall is a testament to the power of human curiosity. We are a species that lives for less than a cosmic instant, yet we have developed the technology to see light that left its source before our own sun was born. We have looked into the zone of avoidance, decoded the screams of dying stars, and mapped the very foundations of the cosmic web. This is the true glory of our kind. Not that we are large, for we are infinitesimally small, but that we can contain the entire universe within our minds. In the face of such enormity, it is easy to feel insignificant. But remember that you are made of the same star stuff that illuminates the Great Wall. The atoms in your body were forged in the same nuclear furnaces that power the trillions of stars in those distant galaxies. You are not an observer of the universe looking in from the outside. You are the universe waking up and looking at itself. The Hercules Corona Borealis Great Wall is not just a distant monster, it is your extended family, part of the same ancient and beautiful lineage. As you go about your daily life, carry this scale with you. Let the brutality of the cosmos be a source of comfort, not fear. It reminds us that our problems, while real, are part of a much larger and more mysterious story. The Great Wall stands in the north, silent and magnificent, a monument to the forces that created us and the infinite journey that lies ahead. Thank you for joining me on this exploration of the biggest thing ever discovered. Our quest for understanding never truly ends. It only shifts to new horizons. There are more giants to find, more mysteries to solve, and more wonders to behold. Until next time, keep looking up, keep asking questions, and keep wondering.